Usachev, who was an associate lecturer here at UNSW. Hi Alex, thank you for taking the time out of your busy schedule to do this.
It's okay.
Yeah, so would you like to tell us a bit more about what you do at UNSW or?
Yeah. So like most of the other people here, have few different roles here. So first I do teach. So then I do research, and also there is a component of an administration. Yeah, so mainly there is three components which pretty much every academic has to do.
Yes, I understand. Yeah. So there's more than just one role that you say that you enjoy teaching here?
I do. I do enjoy it, and I really love it. So I don't know. So for instance, if I will have, I hope I will not ever have this choice, but if I will need to choose between teaching and research, most probably I will choose teaching. So it will be also very difficult for me not to do research, but well, as always, you can do research and after hours, so like a hobby, but you cannot teach as a hobby, because you have to go in class with students, and typically it's from 9 to 5 or 6.
So are you personally passionate about this?
It's hard to say, so I probably never thought about this, but well, I'm interested in mathematics. I'm interested in solving problems, solving difficult and challenging problems. That's I don't know whether you or I can call it passionate or not. Yeah, I do love it.
Yeah. So would you like to expand a bit more what you do for research, or?
Yes. Yeah, so the area is very broadly, it's a pure mathematics. So a bit narrow, but still very broad. It's called a commutative, non-commutative analysis, which can be explained, I at least try to explain that. So we probably teach matrices in 1131. You heard about matrices?
Yes, I have. I think I did a little bit.
So there is a certain rule for multiplication of two matrices. So, but the complicated stuff there about the multiplication of the matrices is that A times B does not equal to B times A, like in numbers. So this effect is called a non-commutativity, so they do not commute. And okay, so that's the matter of the fact, but why there is a huge area about it. So it probably came from the quantum physics. So in quantum physics, in classical physics, to describe something, we use functions. So like the displacement or the velocity, they are functions of a time. So in quantum mechanics, the functions are not sufficient to provide all the information. So we need a different objects, like matrices, or rather infinite matrices. And the point is that when we consider two matrices, and so for every action there is a corresponding action in quantum mechanics, there is a corresponding matrix. And if there are two actions one after another, then the combined effect will be the multiplication of the two matrices. And so in quantum mechanics, it does matter which action was made first and which one was made after that, because A times B does not equal to B times A. And so from this fairly simple observation, the matrices, these infinite matrices, are widely used in quantum mechanics, and somehow we need to do something with that. So this is, again, fairly loosely speaking, the subject of the non-commutative analysis. So what to do in such situations, how to work with infinite matrices, or even with finite matrices.
So there's always more to research about it, and
yes.
As it's very broad.
Yes,
as
always, the research is infinite. We will never study all. We will never prove all the theorems.
There will always new stuff to do. I see. So do you have any other plans for future in your research, or?
Well, as always, again, it works like as soon as you solve the problem, you have typically you have one, two, or even several directions to move from that starting point, from this new, just recently attained knowledge about the solution of this problem. So it always works like this. So solving one problem opens several new directions. So yeah, I'm planning to collaborate. Well, I am collaborating with the Australian and the international colleagues. So I'm planning to extend this circle.
So there'll always be more to
yeah. And it's very good for any researcher to talk and to communicate with colleagues, sometimes from different countries, from different mathematical background, which are doing slightly different or very different mathematics from you, and try to find some connections, some intersections, and find some problems on which, say, both of you can work.
So you have a lot of collaboration between a lot of people, and with that brings in more problems to research on, and so there's no end to it really in the end.
Yes, and it's a bit opposite to the real life. In the real life, we're trying to get rid of the problems. In mathematics, we want to get as many problems as we can. Well, we're also trying to solve them, so to get rid of them, but we are happy if we have a problem.
If we have more to do, yeah. So apart from your research and teaching, do you have any other hobbies that you enjoy, or just outside of this? Or?
Yeah. Well, I will start with a joke. It's fairly old joke. When say some journalist interviewed a mathematician, and the journalist haven't prepared for the interview much. Well, it's difficult for the journalist to prepare for the interview about mathematics, and so that journalist tried to find some points from which they can start the interview, and the journalist asked, well, where do you work? Well, I worked at the university. What department of the university? Well, it's called the Institute of Mathematics. Okay. What do you do in that institute? What's your job duties? Oh, I study the Fredholm equations of the first type. Very interesting. Okay, maybe you have some hobbies, what you do outside of the work. Yes, I do. What is it? I study the Fredholm equations of the second type. Well, it's not like this. It's not like this. Yeah, well...
Would making jokes be one of them? Or?
Yeah. Yes, I like reading, so I read a lot. Well, different genres of the literature. Prefer dramas, psychological dramas. What else? I play tennis. Yeah, so I like the usual big tennis, the table tennis. Yeah, so yeah.
So thank you so much for having us and being able to do this interview. I hope all the best for your future research that you have a continual flow of the problems to do.
You're welcome.
Yeah, thank you so much.
It was a pleasure to be in interview.
Yeah. Yep, thank you.